Next up is ticket number 7. Let's take a look at ticket number 7. R4 can't reach R0's 11:11/128 loopback address. Ensure that R4 can ping this address. Well, sounds like a pretty simple, straightforward ticket. Let's go ahead onto R4 and see if we, in fact, cannot ping that address. Before we try to ping it, let's go ahead and just check the IPv6 routing table. Show IPv6 route 11:11, and the route is not found. Okay, so obviously we're not going to be able to ping it if we don't have a route to it. So let's go ahead and do a show IPv6 OSPF route to see what we do have here. And looks like that particular prefix 11:11 is not here either. Last but not least, let's check the OSPF link state database. Show IPv6 OSPF dat prefix, and we'll include 11:, and nothing. Okay, so now let's go ahead and check our OSPF and EIGRP adjacencies. Show IPv6 OSPF neighbor, and we've got adjacencies with R1, R2, and R3, and that does match what's on the layer 3 topology diagram. Okay, what about EIGRP? Let's go ahead and do a show IPv6 EIGRP neighbor. Make sure we have the space in there. We've got only one adjacency with R5. Okay, let's go ahead and check the topology table. Show IPv6 EIGRP topology 11:11/128, and that prefix is not there. So the prefix does not appear to be in the OSPF link state database, nor is R4 learning it from EIGRP. Now, because R0 should be the source of this prefix, let's go ahead and jump to R0. From here, let's do a show IPv6 OSPF dat prefix, and let's take a look at the self-originating prefixes. Now, the very first LSA here shows the prefix in area 20. Now, a couple of things may jump out at you here. First, look at the advertising router. It's 3333, which is actually R3's router ID. But this LSA is generated by R0. So that tells us that R0 is using R3's router ID. Now, the only reason we know that is because we actually saw that router ID in the last ticket. But let's pretend that we don't know that. Does anything else jump out at you? Well, look at the layer 3 diagram. R0's interfaces facing R1 and R2 are in area 112. R0's loopback is in area 20. Now remember, in OSPF you cannot have a non-zero area connected to another non-zero areas. All areas have to be connected to the backbone, area 0, unless you configure a virtual link. So let's check and see if we have a virtual link. We'll do a show IPv6 OSPF neighbor, and indeed we have a virtual link connected to R1. So assuming the virtual link's configured correctly, that should not be an issue. Let's go ahead and jump over to R1 now. We'll do a show IPv6 OSPF neighbor, and we do have a virtual link adjacency with 3333, which, as we just saw, is actually R0. Now here's how we know that. We also have adjacencies with 3333 on gig 03, which we know faces R3, and gig 01, which faces R0. So clearly we have duplicate router IDs, and R0 is using R3's router ID. Okay, so now that we know that, let's jump back over to R0 and change the router ID to something unique. Let's go ahead and take a look at the OSPF running configuration to see exactly where that router ID is set. IPv6 router, and there it is, router-ID 3333. Let's go ahead and change this to all 11s. We'll do configure terminal, IPv6 router OSPF1, router ID 11.11.11.11, and now we need to clear the OSPF process. So we'll do a do clear IPv6 OSPF process and confirm that we do want to do this. Yes. And notice it says to reconfigure virtual link neighbors with our new router ID. Well, that neighbor would be R1. So let's jump back over to R1 and reconfigure that virtual link. Let's do a show run section IPv6 router. Remember that when you configure a virtual link, you must specify the router ID of the virtual link neighbor. Here, it's configured as 3333, but we just changed the RID on R0 to 11.11.11.11, so we need to reconfigure this. Now, it's going to get a little messy here because it's going to keep spitting out output at us, so I'm going to try to type fast. IPv6 router OSPF1, and then area 112 virtual link 11.11.11.11. I'm going to hit enter here. And area 112 is the transit area. It's the area that we're crossing over to get to area 20. Alright, the virtual link is up now. Let's go ahead and check for the route now. Do show IPv6 route 11:11. And there it is. Alright, now to solve the ticket, we need to make sure that R4 can actually ping this prefix. So back to R4 we go. Show IPv6 route 11:11, and there it is via R1. Let's try to ping it. Ping 11:11, and yes, that works. And with that, we've solved ticket number 7.